So the topic that we are starting with is behavioral finance. Okay. So I wanted to kind of make a pictorial representation. So I spent a couple of hours thinking what would be a good image to reflect what the topic really is. I don't think this is great, but yeah, it kind of takes us very close to what behavioral finance topic is. Okay, so this gentleman here is confused, and confused in terms of different choices he's got in life. Okay. And the more or less this is what the topic is going to show us. Okay, so with some practice you would understand why I put this pictures here. But let us start. The name of the topic, which you can have in your notes, is behavioral finance perspective. Okay, so let's start. The first thing that we want to understand is what this topic is all about. Okay, so we'll do a small example. Maybe you can write down. Let us say we have to choose between two lottery options. Lottery number 1, there is a 33% chance that you will win 6,000, and roughly 66 or 67% chance that you would get nothing, 0. Okay, so this is option number 1. Option number 2, lottery number 2, 20% chance that you will win 11,000, 80% chance that you would get 0, nothing. Which one of these lottery systems would you prefer? You will prefer 2? What do you think, Shubhi? 1? One or 2? I think this is straightforward stuff. There's nothing in this. Quick. What would you prefer, 1 or 2? 2? Okay. See, what is the weighted payoff? 33% 6,000, 67% 0. That means the weighted average is 2,000. And 11,000 into 20% weighted average is 2,200. So given a choice, the lottery that we would like to choose is lottery number 2. Okay, this was the first part of the game. Now second. Now we have one more lottery, and now listen to this carefully, which is made of 2 parts. Okay. The first part, 66% chance that you do not get to play the second round. 66% chance that you do not get to play the second round. Remaining 33% chance that you play in second round. If you get to play in second round, then you have to choose between lottery number 3 and lottery number 4 in advance before playing the first round. Lottery number 3 will give you a 100% assured payoff of 6,000. Or lottery number 4 will give you a 33% payoff of 11,000. Which one of these lotteries will you choose? Lottery 3 or lottery 4? Do you want me to repeat what I said? So this was lottery number 1, this was lottery number 2. Most of you decided that 2 seems to be a better and sensible option. Now we are going to the third system. In this third system we have 2 lotteries, lottery 3 and lottery 4. But it happens in 2 rounds. The first round, 66% chance that you don't get to play any lottery, or 33.33% chance that you get to play either lottery number 3 or lottery number 4. If you choose lottery number 3 in advance before going to first round, then 100% assured payoff of 6,000. Or if you choose lottery number 4, then 60% payoff of 11,000. Which one will you choose? 3 or 4? 3 has 100% assured 6,000. 4 has 33% of 11,000. Sorry, 60% of 11,000. 3 or 4? Alright, so I'm making a flowchart now. Maybe this will help you. How many of you will choose 3? Okay. There was some research done on this, and almost everyone chose lottery number 2 if they had to choose between lottery 1 and lottery 2, and almost everyone chose lottery number 3 if they had to choose between lottery 3 and lottery 4. Now see this carefully. First, lottery number 1, 6,000 payoff with a probability of roughly 33.33%, which gives us 2,000. Or 11,000 payoff with a probability of 20%, which gave us 2,200. The payoff was higher, so you chose lottery number 2. Now this is a second system. 66% chance that you do not get to play the second round. Roughly 33.33% chance that you get to play the second round, in which you choose either lottery number 3 or lottery number 4. Lottery number 4 gives you a payoff of 6,000, 100% assured. And lottery number 4 gives you a payoff of 11,000, 60% assured. So let's calculate weighted average payoff. 33% into 100%, that's a weight of 33%. 33% into 6,000, that gives us weighted average payoff of 2,000. 33% into 60% is 20%. 20% into 11,000 gives us a payoff of 2,200, which means what you people did was, in this case you chose 2,200, whereas the same data presented differently, you ended up choosing 2,000. This is called as a framing bias. Framing means a lot of investment decisions would be taken based on how data is framed rather than how the actual data is. Okay, and this is your introduction to level 3, that a very big part of your syllabus would be focused on how individual thinks before taking an investment decision. Okay, and that precisely is the behavioral finance. Do you want to argue on this? No? Should we go ahead then? Okay. Alright then, so let's start. The first point of discussion, traditional versus behavioral finance. Your hands should be working fast. Okay, so I would recommend making quick notes of everything that's happening. This is the first point of discussion, traditional versus behavioral finance. So what is traditional finance? Whatever we have been learning in level 1 and level 2 was traditional finance. Okay, so CAPM that we studied was traditional finance, FEMA and French traditional finance, everything that we've been studying so far traditional, and this is more or less in a manner prescriptive in nature. Prescriptive means it will give you the solution. It will tell you that okay, this is what you're expected to do in this particular situation. Behavioral finance, on the other side, is more of how an individual and how markets behave and react to a particular situation. Okay, so this is still an emerging area. A lot of new work is done into this. So at this stage, behavioral finance is not really completely prescriptive, but more on the descriptive side. That means very rarely you would find behavioral finance giving you a solution to a problem. Rather, behavioral finance would more identify what could be possible problems and how you should be more careful about them. So more descriptive in nature. So traditional finance is more prescriptive. It explains how investors should make investment decisions based on mathematical models and theories. What is very important here is an assumption of REM, which is the people are rational. Second very important assumption, people are risk-averse. Have you studied risk-averse in the past? What does it mean? Yes, for a given level of return, they would want lower risk or vice versa. And utility maximizes, they would want to have maximum utility, and this is in a way drawing from your level 1 economics now. They want to have maximum utility for given set of constraints. Okay. Uh-huh. Yes. So that's what I'm saying. Yes. Because I framed it differently, it was the same lottery. Lottery 1, 2, and 3, 4 in a way was same, but only because it was framed differently, you ended up choosing a different lottery, which is a behavioral bias. And as I said, behavioral finance is more of in a way descriptive in nature. So it identifies that okay, there is something called as framing bias, where depending on how an investment is framed, investor would choose it in that fashion. Going forward, so we have covered this point that behavioral finance is descriptive. It explains observed investor decision making. It draws concepts from traditional finance. Okay, so to some extent, even a little bit of maths that we would be going through today. Psychology, of course, very heavily, and also neuroeconomics. What does it mean? Which is again combination of cognitive biases, combination of psychology and economics mixed together. Okay, so that's called as neuroeconomics. It comes in two parts, micro and macro. Can you guess what would be micro? More on individual side, like what you just did some time back, that how would an individual react, and macro would be more on the entire market side, right? So in certain events of catastrophe, the entire market might behave in such a way which would be against the traditional finance theories, and then those areas are typically studied into macro behavioral finance areas. This is what you need to remember. And now please remember that in level 3 in the morning section you have to write constructed response, which means very unlikely, but which means there is a possibility that you might be required to list down all the 4 options. Okay, and that's a completely different ball game from level 2, because now what it tells us is that we have to remember which were the 4 axioms of utility. Now, can you tell me what is completeness? In your economics, this was more or less referred to as level 1 as absolute preference. What does it mean? It simply means you should have ability to choose or decide. Okay, in a very simple language. For example, let's say we have 2 options, A and B. So you should have ability to choose either you want A or you want B or you want none of them or you want both of them, but you should have a ability to take decision based on this. So that's called as completeness, one of the axioms of utility. So we are kind of going to draw from utility theory now. The second one is transitivity. I'm sure you must be knowing this. What is this? Yeah, similar. If you prefer A over B and if you prefer B over C, then you have to prefer A over C. Okay, this is called transitivity. We had this in level 1 as well. The third one is independence. What would this mean? That means your selections are independent of the extra variables. For example, let's say you have a preference of A over B. Now, some C element is added, which is also a positive element, positive utility. So now you are being offered 2 choices of portfolio, A plus some fraction of C and B plus some fraction of C. So it cannot happen that the moment C is added, your preference should move towards B. Okay, so you should have an independent choice, meaning of which is if A is preferred over B, A plus 0.5 C should always be preferred over B plus 0.5 C. Am I making myself clear? If changes, then of course then it goes to the first point. So as long as the proportion of C is constant, this is true. If it changes, we can't really conclude that. And the last one is continuity. Okay, what this continuity tells us is that investor has a continuous utility curve or utility graph, and any point on that graph on the indifference curve is giving us the same level of utility. So which means that we can create infinite number of possible set of consumption of goods or consumption of portfolios that all of them would have exactly same level of utility. So which is called as continuity. So these are the four axioms that you should be able to reproduce as it is. Okay, and if they give you an example and ask you that which one of these axioms are violated, you should be able to figure it out and also list it the same wording. We'll do few examples today. Make this flowchart, then we have some discussion. This is kind of a core part of the reading now. This part we have already seen in level 1 portfolio management. Now what is additional that we learn here? These risk averse investor, the ones who do not like risk so much, so for some X amount of gain there would be a amount of increase in utility. For example, if their wealth increases by an amount of X, their utility will increase by some amount A. If the wealth decreases by the amount of X, the decrease in utility would be much more higher than A. These are the investors who are at risk averse. Okay, I'm framing this sentence again. For some amount of increase in wealth, the increase in utility would be less than decrease in utility if the amount of wealth decreases by the same size. For example, if the wealth increases by 100, then utility might increase by some variable 10, some unit 10. But if the wealth decreases by 100, utility will decrease by more than that, 20. Then these kind of investors are called risk averse. Okay, so if you want to put this on a graph, on x-axis you put the wealth, on y-axis you put the utility. Number one, can you tell me whether this graph should have a positive slope or negative? Positive, because when wealth increases we would want utility to increase. But should this be a straight line or should this be a curve? It should be a curve because the slope is not constant. Should the curve be concave or convex? It should be concave. The reason being that the increase is happening at a slower speed but decrease is happening at a faster speed. So what you would remember is that risk averse investor would exhibit a concave utility curve, and the meaning of concave utility curve is decrease in utility for a given level of wealth would always be higher, given level of decrease in wealth would be higher compared to increase in utility for the same level of increase in wealth. Risk neutral investors on the other side are said to be having a linear utility function. Okay, and that's why they are said to be risk averse. So as the wealth increases, proportionately utility increases. If the wealth decreases, equal amount of utility decreases. Risk seeker are exactly opposite of what risk averse people were. So when they have positive wealth, the increase in utility is higher compared to a scenario where there is a negative wealth, decrease in utility. So which means again it's a positive slope, but should be concave or convex now? Now it should be convex. So now it works this way around. This side is utility and this side is wealth. Convexity, yes. But there it was a negative slope there. It was convex, but interest rate and bond prices, the duration convexity, that was negative slope. This is positive slope. So how you can think of this? See, if you see it's growing in this fashion, that means it's growing really fast on y-axis. So convex. Increase would be faster. In this case, it is increasing like this, which means that increase in utility is happening slowly. Are you following what I'm trying to say? So therefore this is convex. Convex. Yes, even this, but other way around. Both of them. Are we good to go ahead? Alright, this is something that you already know. There are a few examples given both in curriculum and the notes. Okay, so we do a couple of them. May I assume you know this? Bayes theorem? No? Yes. Probability. Let's try. Let's see if we remember this. Let us say probability of increase in EPS. Probability in increase in EPS given we have a good economy. Given we have a good economy is 30%. Probability of increase in EPS given we have, so let me call good economy as probability of G. So this would be probability of G complement, which means increase in EPS given that economy is not good, let us say is 20%. Okay. Then there is a 40% probability of having a good economy. Now what updated information you get was the updated information. Bayesian theorem or Bayes theorem is used for updated information. So what updated information you received, that EPS actually did not increase. EPS did not increase. So what is the probability of that it was a good economy scenario? This is Bayes theorem. Okay, let's do it together. So you build a binomial tree for this. First, you always start with independent events. Probability of good economy is 40%, which means probability of good economy complement would be 60%. Okay. Now, if it's a good economy, then increase in EPS. So let's call this as probability of E. So increase in EPS is how much? 30%, which means not increasing EPS is 70%. Again here, if it's not a good economy, increase in EPS is how much? 20%. Gail, which means not increase in EPS is 80% because total has to be 100. So now we calculate joint probabilities at each of the node. So 40% into 30%, 12%. 40% into 70%, this would be 28%. 60% into 20%, 12%. 60% into 80%, 48%. Okay, this is the basic work that you do. Now what is the new information that you've received? New information is that EPS did not increase. Which are the scenarios where EPS is not increasing? This 28 and this 48. So these are now considered as true scenarios. Once you know a true scenario, you calculate Bayes updated probability. So what is the probability of good economy? Good economy was this. So 28 as a ratio to 28 plus 48. This is the probability of having a good economy given EPS did not increase. And 28 as a ratio to 28 by 48, that would be 76. How much is that? 28 by 76. How much? 36.84%. First in, first out. What you studied at level 1, out at level 3. Was this a part of the syllabus? Of course, yes, it has been part of the syllabus when I wrote my level 1. Will you be able to deal with this? Should we go ahead? Please answer the question. C. Why is A? C is the correct answer, yes, I agree. But why is A not the answer? Not necessary. Because it is not prescriptive, it's more of descriptive. So not necessary. Of course, this is absurd. This was never the answer. The correct answer was C. Is it okay?